My talk is Kubernetes Cloud Cost Monitoring with OpenCost and Kubernetes Optimization Strategies. So for those of you who I don't know, it's great to see all y'all. Thanks for coming. I'll make the slides available afterwards if you want to. You don't have to take pictures of all of them. They'll be up on SlideShare from my LinkedIn, all that fun stuff. So this is not my first scale. It's not my second. It might be my third or fourth. But I am currently the Senior Community Manager for OpenCost at a company called KubeCost. And I'm also the co-host of the Software Defined Talk podcast, if you're a fan. I moved to Australia, actually. Fun story we can talk about later. About 6.5 years ago, and originally from Austin, Texas. And I was one of the organizers, one of the founders of the Texas Linux Fest, which is actually a syndicate of scale, which is fun. And so there you can find me on the old email and LinkedIn, and I replaced Twitter with Mastodon, but it's actually Matt Ray at Hackaderm if you're into Mastodon. So the complexity of operating Kubernetes efficiently is it's a real problem. I mean, you've got a lot going on with Kubernetes. Is everyone using Kubernetes? Because if you're not, you might be in the wrong talk. Because I'm going to be assuming a certain level of understanding. But I mean, Kubernetes brings both technical and behavioral complexity to the problem. I mean, you've got a lot of great tools as an operator. You're able to deploy this across disparate infrastructure and get nice high-level abstractions for your developers and your operators, so they can have something that works across all this stuff. But at the same time, a lot of the complexity is abstracted away from developers, which is good, and operators, which is less good. And people aren't actually aware of how much money they might be spending as they do things. They're just, hey, I stood up some stuff, it's rolled out, it's somebody else's problem. But eventually you'll get to having to answer questions like, why is this cloud bill so high? What caused last month's bill to skyrocket? What's going on in our cluster right now that we've seen a whole bunch of instances spin up, and things are again getting more expensive. And so a lot of this comes back to cost, but the efficiency of your infrastructure is directly tied to how much you spend, right? Things are going to fall over if they're way oversupplied because you've spent way more money than you should have. So what we want to do is kind of find the right balance before you blow through $100,000 accidentally. So luckily, there is help available. OpenCost is it's not only is it open source, but it is a cloud native computing foundation project that was added to the CNCF last June. So it's still fairly new, but it came from a company called KubeCost, who's my employer. It's not new. People have been using this thing in production for years, but they contributed it to the CNCF, renamed it to OpenCost, and now we're building up a community of users and adopters around it. Not only is it a CNCF project, Sandbox project, but it's also a Finops certified solution. So if you are aware of Finops Foundation, they're actually part of the Linux Foundation. I'll talk about them some more in a little bit, but they're trying to educate people on cloud finance. How do you make sense of what you're spending in the cloud? And so it's OpenCost just happens to be the only CNCF and Finops project. There's some websites, GitHub. We'll come back around to all this in a little bit. But OpenCost is both a project and a specification. And so the specification is where we actually define how this stuff works, right? I mean, Kubernetes is complex. Cloud bills are complex. We want to know what's going on as we tie these things together. So the OpenCost spec is a vendor-neutral open source specification that KubeCost wrote in conjunction with all these other companies. There's cloud providers, there's end customers, there's folks in the middle. But we wrote the spec with a whole lot of real-world Kubernetes practitioners to kind of understand what's going on in our builds. And so the OpenCost specification, there it is up on GitHub if you want to go read it. But it's for measuring and allocating your infrastructure and container cost to Kubernetes. Essentially, you have a cloud bill. If you go to your AWS Cost Explorer, you see a nice EC2 other. You have no idea what's happening inside your cluster, inside of Kubernetes. So what we want to do is be able to track your Kubernetes spend, which a lot of times your containers are coming and going rather quickly. They might not be around an hour. They might be around for 5 minutes or less. And so things are very transient. They're vary a lot. But within your organization, you're going to want to measure who's responsible for what, right? You're going to want to be able to say, like, what are the management fees on top of this? What expenses come from our nodes? What comes from persistent volumes, disk, load balancers, network ingress, egress? This is what OpenCost will hopefully answer. And so when we start talking about our costs, the first concept is our total cluster cost, right? This is how much does it cost to run Kubernetes? For sake of examples, I'm going to stick with EKS, the Elastic Kubernetes Service on Amazon. There's just kind of two parts to it. You have a cluster overhead cost. You deploy EKS, you're paying a management fee to have a cluster. It doesn't matter if it's 5 nodes or 5,000. You have cluster overhead cost. That's not super expensive, but it's there. You get that, and then you have what we call cluster asset costs. And an asset, a cluster asset is the things that you're paying for to run that cluster. This is, in our Kubernetes cluster, it's your compute nodes, their storage, and their networking. And when you look at your asset costs, it's not just, we have kind of two pieces. We've got our allocation costs and our usage costs. Allocation is stuff that you've asked for it, they've given it to you, you're not paying by the use, right? So if we were looking at something like, I don't know, Beanstalk or CloudWatch or something, you're paying by the message. You're paying by consumption-based. Allocation means you asked for it, we gave it to you, the clock is running, right? We don't care if you do anything with it or not, right? Maybe you don't use that EC2 node, maybe you do. Maybe you run it at 100%, maybe you run it at 2%. They don't care. You're paying the same amount. Usage costs are by the usage, fairly straightforward stuff. That's networking costs, especially. Some storage falls into that category. Some storage falls into allocation. It kind of goes both ways. But those are our direct cost of that cluster. And as we kind of bring that into a node example. Your EC2, your cluster, your EKS cluster is going to be running on, let's say, 5 nodes. That cluster management fee stays there at all times. You're paying that, but that is going to break down into, our resource allocation is, the node, the persistent volumes, the load balancer. You're paying to have it, and then the usage, it's network. And that's pretty straightforward. It's a simplification, but that's how we kind of think about these sorts of costs. So we've got the cost of these assets. I know what my EC2 bill looks like. Now we want to go and map it back into Kubernetes, right? We want to go and actually see where these things map. And so within our Kubernetes cluster, we have these kind of five things that we're measuring: CPU, memory, GPU. We get that from the node. We don't really know a whole lot other than this is what we have. But on the Kubernetes side, these are the kind of different axes we might want to look at, right? You might want to say, hey, I want to know how much I'm spending by a label, a tag, or I want to look at how much a particular namespace costs because we have a dozen customers, each one gets a namespace, and I want to be able to do chargeback to my dozen customers. And I can't just charge them all the same amount. Some of them are going to be using different amounts. If anybody has questions, feel free to slow me down. I'm going to run out of slides before I run out of time, probably. So as we come back to our total cluster costs, we still have our overhead costs. Those aren't going anywhere. But we've figured out what's been allocated for our cluster, right? We spun up our 5-node EKS, and we have some workloads running on it. We've got, who knows what our application is, but, we're running WordPress, and we're running it across 4 nodes, 3 nodes, whatever. It doesn't matter. Kubernetes doesn't really care too much unless we start, diving into Affinity. But we also have what we call cluster idle costs. This is, you're paying for those 5 nodes. It doesn't matter, again, if you're using them 100% or 2%, you're paying for them. And so we call that cluster idle costs. This is the overhead of the cluster that you have not allocated to your Kubernetes workloads. And so that's just, some people call it waste. Some people, we prefer to call it idle. But that is just overhead that is not allocated to your Kubernetes spend. And if coming back to our allocation costs and our usage costs, it might get split across some of that. You've probably over-provisioned your networking or over-provisioned your compute. We're just showing like, hey, these are the same things across the board. But these are, the workload costs are directly managed by the kube scheduler, right? So this is something that Kubernetes said, I want this there, and the rest of it is left over. But you're paying for it. You're just not directly using it to run your application. And then that, of course, we had our allocation and our usage concepts. Those, again, apply within the Kubernetes cluster itself because, we're paying for, networking by our Kubernetes. We're paying for, EC2 nodes that have been allocated. And so when we talk about idle costs, this is, any unallocated cost that Kubernetes is not consuming. Again, some people call it waste, but it's not always waste, right? You might say, I would love to run my Kubernetes cluster at 100%, because then when I order one more pod, oh crud, I ran out of headroom. So, a lot of times you have to give yourself some headroom, but we want to find kind of the right balance between, having a little bit of idle headspace for your workloads and, wasting money. And so when we talk about idle costs, that can be at the cluster level. I said we've got 5 nodes, but we're really running, 3 nodes worth of compute. I've got 2 nodes that are idle. Or it could be at the workload level. I've defined my pod. I said that Nginx would like to have 4 gigs of RAM, please. And Nginx really only wanted 200 megabytes. But that's idle because I've allocated it for Nginx, but I'm not actually consuming it, or I don't actually need it. So idle is it's not contentious. It's just you have to figure out what's the right health for you. And for a lot of shops, as soon as they point OpenCost at their infrastructure, they're going to find some kind of eye-opening idle numbers, like you're probably running around 10% efficiency. Maybe you're okay with that. Maybe you need HA. Maybe you need extra capacity. Maybe your workloads are bursty. We could talk about improving efficiency later, but I'm kind of hammering on it because it is important to understand what idle cost means, and it's not just waste. But one of my coworkers was pointing out to me yesterday that idle is what platform engineers call it. It's about what the person who pays the bill worries about idle, and engineers or developers care about efficiency, right? Developers want to get the most that they can for their compute. And whoever's paying that bill wants to make sure that they got enough but not too much. All right, so I understand now. I get it. I'm measuring allocated. I'm measuring I've got all this in concepts are mapped in my head. Hopefully, I'm not going too fast. But how do we get those metrics? So coming back to OpenCost, OpenCost is actually pretty simple. It's got a fairly straightforward architecture. OpenCost uses Prometheus both as a source of data and as our data store. So OpenCost is going to be querying KSM and C-Advisor to get information about the nodes running Kubernetes, pulling up information about your Kubernetes cluster, and Prometheus Node Exporter is going to be surfacing some of that data too, and then OpenCost just scrapes that data. Thank you, Prometheus, and puts them back into Prometheus. That's the simple part, and then they're going to go to our Kubernetes API and our billing data. So OpenCost talks directly to your billing APIs. It's not parsing your bill. It's actually just finding the on-demand prices. So we stood up our EKS cluster. We go to the Amazon API and says, hey, I've got 5 nodes of EC2 running in US East 2. How much does that cost an hour? Now I got my cost, right? OpenCost does not parse your bill. It's a heck of a lot of work. It might get open source someday, but for now we don't have the engineering available to the open source side of things. Yeah, we'll just leave it at that. So it's on-demand pricing. Deploying OpenCost, it's super simple. It is, first you have to get Prometheus or a Prometheus-like API. So people definitely use OpenCost with pretty much everything else. Victoria Metrics, Cortex, Thanos, Mimir. Prometheus API is really popular, and all we need is PromQL to work. But you need a Prometheus. We generally recommend the Prom Community Helm chart as our default because it just works, and everybody else uses it. You can deploy OpenCost with either a manifest or a Helm chart. Of course, you could write your own, but the manifest is super simple because it's a namespace. We prefer the OpenCost namespace. It's a few sets of permissions to make sure that OpenCost has access to all your internal Kubernetes APIs, and then it's a deployment and a service. It's a 2-container pod. One container is the service, the other is the UI. Pretty simple. Does not have much of a performance impact on your cluster, unless it doesn't really have much impact. But of course, it measures itself, so you can see how much it costs. And then there's a Helm chart, and the Helm chart has we've got a fair amount of open source activity happening there with lots of people saying, oh, you need to support this use case and that use case. But if you just want to do plain vanilla, the manifest works great. The Helm chart will let you turn a lot of knobs. Whether it's how you deal with Prometheus or whatever it might be. But there's no real configuration of having to do your cloud credentials or anything because we're just using public APIs. I think Azure, you need to put in like a key. I could be wrong on that, but just the billing API is available, but you have to make sure that you have a token to talk to it. But that's about it. AWS, GKE, they're going to just work with whatever. OpenCost does work on-prem. So if you have, hey, we run Kubernetes in our data center, we have some sort of concept of chargeback or internal pricing, OpenCost will allow you to do like a custom pricing sheet. You can say like, my nodes cost $1 an hour, memory costs 50 cents an hour, and it'll take it from there. So it's pretty simple to deploy. And again, most people don't actually customize anything. They just deploy Prometheus and OpenCost, and it starts working immediately, which is great. And what does that give you? In about 5 minutes, you start having enough data to start running reports. All the data is stored in Prometheus, and so we have an API. The API is fairly simple. I'm not going to show the API. I don't have it in my slides, but I have it in my browser. It's a really simple API because really you're just telling it the period of time that you want. Support a whole lot of options of different time formats. You can say like I want the last week. I want here's a Unix timestamp to another Unix timestamp, or I want whatever it might be. You pick what granularity of time you want. By default, OpenCost is measuring every minute. You could go below that, but generally it starts to get into some performance issues. If your containers are not living longer than a minute, you might miss them. Most people don't have that problem. Again, you can lower that if you really care, if you need to track sub-minute, but we're not really focused on that too much. And then, of course, the API allows you to choose what you're aggregating over, right? And you can have multiple aggregations. So I can say, I want to aggregate, I want to see everything in a particular namespace, and then within the namespace, I want it further broken out by stateful sets. So I can see all the stateful sets broken down after we've sorted them out. So you can do like, mixing tags are what a lot of people are gonna mix with, namespaces and tags. So the API is pretty flexible, pretty powerful. It comes back as JSON, and then you're off to the races. There is a web UI. I think it's in my next slide. I'll show what that looks like. Yeah, I was gonna say I can try to get that working, but I lost my desktop. There we go. Yeah, so it does have a web UI. It's pretty straightforward. There's no auth. Don't put this on a public-facing thing. Just run it with a kubectl port forward. And there's a CLI. So there is a CLI called kubectl cost that allows you to make all the same queries, and you can get your stuff back in nice tabular format or CSV, whatever it is that you want to put this data into. Go nuts. And then, of course, if you, for whatever reason, you want to directly talk to Prometheus, that's there too. So you can go and make all your own queries of all this fun data, which, it is fun. Any questions about consuming the data? No? Yes? Yes, yeah. So Prometheus is holding, by default, 14 days, which is, it's putting on a persistent volume. If you kill your Prometheus, by default, you'll lose your data. But you could put that on, a storage. You can add a mount point, or put it on NFS, or wherever you want, and back up your Prometheus. But yeah, I have accidentally gone into demos where I'm like, let me just restart my cluster, and oh, there went all my historical data. So yeah, fun tip is the community Prometheus doesn't store your data. Yeah. Not yet. So that is a frequent question of, can I tell OpenCost, this is what I want to deploy, how much is it going to cost? KubeCost, the kind of commercial parent that they offer that feature. It's not to say it won't show up eventually, but we're kind of diverging in engineering, so. Yeah, well, that's what I'm saying. Like, KubeCost does that today. So if OpenCost, I'm about to show you some slides that say OpenCost is going to do whatever you want it to do, because we need engineers. I mean, KubeCost is my employer. They do a lot of engineering work on it, but they have their own feature set, and I don't get to just pull their features. I have to implement them separately, which is, we are diverging in some other ways. But projection, price projection is a frequently asked feature, but it's not number one on our list. So I'm about to talk about roadmap. Yeah. No, it would not. So that's, again, KubeCost does that. So if you're unfamiliar with the cost and usage reports out of Amazon and Azure and Google and the like, you don't get your bill immediately. You get your bill within, hopefully, 72 hours, because they're constantly calculating how much did you actually use and what kind of discounts did you have negotiated. And so what KubeCost and other tools do is they look at the S3 bucket that holds your report, and they then reconcile it with the on-demand pricing. So they'll say, oh yeah, this cluster costs, $50 an hour, and that's right if you look at it at the hour. But then when you go and you check your bill, like, oh, I only paid $32 an hour, right? It's because you had some sort of savings plan or reserved instances. But like with on-demand pricing, we'll never know that. And so that reconciliation of real-time versus historical and making sure that things sync up eventually, because it doesn't just like pop, here's your bill. It's like, here's a line item in your bill. Here's a line item in your bill. That stuff it's a lot of engineering work. So today, OpenCost does not do that. It's not to say that KubeCost or someone else won't open source that work, but today it is just on-demand billing. Yeah, go ahead.
So on the same question, you also said that point OpenCost your own billing.
Yes,
Right?
yes.
So does that mean that, how easy or not easy it is to create your own billing?
It's super easy, yeah.
Because I'm saying if you have your accounting cost, let's say,
Yep.
from the cloud, or so
You could, yeah. So are you in our Slack? Because somebody asked that question yesterday. To sum up the question, can you override line items in the on-demand billing? Is that a better way of putting it? Yeah. So let's say, that if I go to AWS and I say, how much is an EC2 node, particular EC2 node, it says, this one costs, $1.25 an hour, but you have already negotiated $1 an hour. And so you can go and say, well, I would like to override just that line item. You can do that. It's not documented. And I'm working on documentation because I didn't think it worked. And then somebody was like, it kind of works, but it blows up other parts of my AWS on-demand pricing. And I'm like, okay. So as of today, the state of documentation is there is a default pricing JSON for, hey, I want on-prem pricing. I got that. And then with a config map, I can upload a CSV. And I can say, oh, I want to override. I've got 5 kinds of nodes and 5 GPUs in my data center. I get that. And if you keep going down that path, you can say, well, here's my AWS pricing JSON, override some of the line items, and I can override individual things in that bill, or in that API request. Because it's not the bill, it's the API request. And so it'll knock those out of the response. And the community person was like, it changed my numbers, but they're broken. And so he opened an issue yesterday. Again, it probably will work. I just haven't got it documented straight. Yeah.
Are you alone?
I'm pretty much alone in this. So, well, I'm not completely alone. So let me. I think we'll talk about.
Sorry,
yeah, no. I'm not completely alone, but I'm kind of alone. So this is the UI. It's if you are a node person, I did not build this, but I've now got node patches because I've fixed a few small things. If you are a UI person, this is a great source of first issues because nobody really gives this thing any love, and we could put more of the API, we could expose more of the API because all it is it's just a front end for the API, but it doesn't support multi-queries, so you could be able to chain a bunch of aggregators together, and so you could drill down namespace to deployment to whatever. So there's some fun things you could play with there. There are some things available in the API that aren't in the UI that you could update, but it just works, right? It works. It's not fancy, but it doesn't have to be. And so what's the future of OpenCost? Like I said, OpenCost became a CNCF Sandbox project in June, so it's still pretty young. Most of that time, I started working on OpenCost in November, so still pretty early. And mostly we've been cleaning up documentation. So I'll continue to point out, yeah, it works, it's just not documented. Because there's this divergence of what KubeCost does and did, and what OpenCost does that's different. And there's not a lot of KubeCost engineering. So the real question is, what do you want OpenCost to be? You know, so people are like, I would love to see, you know, projections. Like, I'd love to see that too. I'm not probably going to have all the cycles myself to do that, but I can, you know, we can all look at the KubeCost implementation. It's just not open source. You know, and we can see how you could pull these numbers and you know, implement it yourself if you want. And no one's going to say no to a PR because it's a CNCF project, right? It's Apache licensed, and you know, we're fleshing out the governance model, but essentially it's like nobody's going to tell us what we can't do because it's a CNCF project. What's on the near-term roadmap? So what's being worked on? So there are definitely other companies involved in this. I just, you know, because I work for KubeCost, I became the community manager because somebody had to do it, and you know, they want this project to succeed. There's no, you know, we've got shared booths and all that fun stuff. But some other companies have gotten involved. You know, Grafana Labs is one of the biggest or most active. They've showed up and they, you know, they're like, hey, you know, your Prometheus queries are all slow and this is why, and you know, you should have some Grafana dashboards and let us help you with that, and you know, your Helm chart sucks, and you know, so they, no, I mean, in a good way, in a good way. They showed up with patches. They showed up with documentation and patches and engineers, but then they were like, you know what we would really like to see is the cost of our S3 buckets. And S3 is not deployed by EKS, right? You know, spoiler. And so they started saying, we'd like to see S3 cost. We'd like to see external network cost, not just the, you know, within our cluster, but actually the cost of, you know, what our workloads are touching. We want those costs too. And other folks have shown up in Slack and in our meetings and said, you know what I'd really like? I'd like to map my Datadog or Splunk back into Kubernetes. I'd like to know how much Splunk costs per namespace. You know? And I'm like, that sounds great. I'd like that too. But you know, OpenCost does not support that. But we have a working group that we've started that's called the External Asset Costs Working Group. Name is still TBD. The word cloud was in there, and then we want to give the on-prem people some love too. But you know, external cloud assets. This is things that they're not in your cluster, but you want numbers about how much they cost tied back to Kubernetes. And so we're literally like 2 or 3 weeks into this. Grafana Labs is, S3 is going to be our reference implementation. They're working on that. We're working on a spec and an implementation at the same time. But some of the folks from the Finops org have showed up. And what they've showed up with is the Finops Foundation is working on what was called the Open Billing Initiative, and now it's called FOCUS, and I'm not sure what the acronym stands for. But essentially, they want to provide a standardized API for all cloud bills, and then you just put whoever behind it, and everyone just talks to the API of the billing API, and magically you get, you know, object storage costs. Well, we'll see how that goes. But they showed up too. And so really, what's going to happen with external asset costs is, you know, this is a divergence from KubeCost because they already kind of have their version of that, but it reads the bill and it is specific to the cloud provider. It has no concept of Splunk or Datadog or anything like that. So, you know, they're tacking different directions. So external asset costs is a great way to get involved if you have some thing you would like to see tied to your data in Kubernetes. Like, this is the way to come in because we're going to have, we're going to finish with an API, a reference implementation, and if you fit the contract, you can show up in the API and the UI for OpenCost. And then you can say, like, how much does my namespace cost for Databricks, or whatever it might be. So that's coming. There is over on the Backstage project, the CNCF Backstage project, they've got an issue open. Somebody said, I want to see billing cost, specifically OpenCost, just being one of those default plugins for Backstage. Anybody in Backstage involved? Please hit me up, because I have no idea, but I'm going to go do it after scale. So I figure it can't be that bad, because lots of other things are plugins. Huh? How hard can it be? Yeah, says the crazy guy. So yeah, Backstage integration. That's on my short-term roadmap, probably before hopefully before KubeCon EU, we'll have something to talk about there. More clouds. You know, people show up all the time and they're like, do you support X? And I say, here's a design doc for how you can implement X. And so what you get out of the box right now is, Amazon, Microsoft, and Google, and on-prem. What there is rudimentary support for is Alibaba, Scaleway, and I think some Oracle patches are coming. So if you were like, hey, what about DigitalOcean? What about, you name it, IBM or, whatever your cloud might be, patches are always welcome, right? It's not that hard, famous last words, it's not that hard to implement a new provider because really you're just hooking up a billing API to the primitives of nodes and, containers. Yeah. Oh yeah, Azure's definitely supported. Yeah. We have, there's an Azure project manager who pokes around in our Slack channel a lot. And, I don't know if he's kicking OpenCost around or KubeCost, because commercially there's some, relationships happening there that, they like to talk to each other. But like everybody wants the CNCF insurance of, well, if the commercial company goes away, we have this great open source thing that everyone can use. So, yes, it does work. It definitely works. No, it's not perfect. None of them are perfect. Before I switched to working on OpenCost, I worked in customer success, where I worked with our biggest customers, and man, we found weird things. But it was really a fact of the matter, like, new things show up to be billed for all the time. And new features come up in the clouds all the time. I had a customer who was using premium SSDs that did not exist with Kubernetes 1.17 because that's what they deployed with and hadn't upgraded in 4 years, right? And so it's like, well, of course it's never going to work, but that's the kind of stuff, like, there's always a mismatch, but we can keep refining it and making it better. We are currently released, KubeCost Engineering does release OpenCost today. They release monthly, so there was a new release today. I haven't gone through and updated it yet, but we are constantly releasing it. It's all open source, like, the complete transparency. It's just OpenCost does not have its own like agency yet for deployment for engineering enough, because KubeCost folks take all the patches. They don't, there's no questions. I just like, and I've given commit bits to several non-KubeCost people. OpenCost is in its own project. It's just, we're still a sandbox, right? We're getting our feet under us. But yeah, and so documentation is always, we always need more documentation, whether it's, how to get Azure configured exactly right, or how to, get the AWS API line items overridden. It's like, it worked. I just, hours in the day. And of course, more integrations are always welcome. We love to hear about how you've got whatever it might be. And so external asset costs, I think, are going to be an easy on-ramp for a lot of folks to get involved. You might not be involved in the OpenCost day-to-day, but external plugins are going to be big, I think. And I didn't really mention it, but it's all written in Go. It's not particularly, it's not particularly slow. It doesn't need to be particularly super efficient, and Go's great for that. So we're not rewriting in Rust. So yeah, if you would like to get involved, OpenCost.io is the website, which is up on GitHub. You can go and update the website if you like. We have our Slack channel over in the Cloud Native Computing Foundation's Slack. There's about 250 or so people. It's growing every day. A few people join. GitHub, we have our own org. We have 3 repositories currently. The website, the Helm chart are all community. OpenCost is, some KubeCost, some community, but it's all open source. Completely transparent and all that fun stuff. And then every 2 weeks, Thursdays at noon Pacific, we have what we call the OpenCost Working Group meeting, which is those of us who are working on it kind of show up and talk about like, hey, what do we need to talk about face to face? And we definitely encourage end users who are not developers to be there, because people show up and like, hey, I was trying to get this to work. And maybe you were having a hard time explaining what you wanted in Slack, and oh, by the way, now we're using a Zoom, and you could do a screen share and show me, or whatever it might be. So it's both like working and community, whoever shows up. And then we have a calendar, of course, so you can subscribe to that. And other things on the calendar are like the external asset cost working group, which also happens then, LinkedIn, if you're into that kind of stuff. So that's the OpenCost project. Any questions about OpenCost? Yes. You can definitely do that. Yeah, so to repeat the question was, I've got multiple clusters. I'd like to see them all aggregated together. OpenCost is single cluster deployments. It's a Prometheus, and there is a patch inbound from Grafana Grafana Labs does exactly what you're talking about. They run thousands of instances of OpenCost, and they roll it up into Mimir, their big, PromQL compatible open source database. They do that. They've got a patch that they were going to submit to OpenCost to make it so you can redirect and relabel your cluster outputs. So, because right now it just calls everything like cluster one, cluster one, cluster one, and you only ever look at cluster one. But they've got a patch to, say, well, it's cluster two, put that tag in it and push it into, Mimir or Cortex or, a bigger Prometheus. And then it'll, you can do queries and stuff against that. So you can do it, it's just not out of the box. If you want it out of the box, KubeCost offers that feature, of course. So yeah, my employer, I want them to succeed too. There's plenty here for everybody. But that's OpenCost. I'm going to pivot now. Oh, Noah. Like what kind of selectors? Oh, so within OpenCost, there has not been a lot of like query optimization work. It's coming, I think, from the Grafana guys. Like, they've already gone through and done several passes about how bad we did everything Prometheus-wise, right? Because that's literally their day jobs. And so they came in with a bunch of those patches. They probably, if you show up in Slack and talk to, hit me up and I can tell you who to talk to, like the Prometheus guy or the Grafana guys, because that's literally what they do. They're not using Thanos, they're using Mimir, but it's the same problem. So yeah, they can help you out for sure. Yeah. Any other OpenCost questions before I kind of pivot? All right. So we got our numbers. What are we gonna do with that, right? How am I doing on time? Okay, we'll keep it quick. So the first thing is, if you are an organization of more than like, I don't know, one team, you probably want to start thinking about Finops. Finops is, the Finops Foundation is a group within the Linux Foundation, yet another foundation, kind of like the Cloud Native Computing Foundation. Their goal is to provide guidance on how to do cloud financial management with best practices, education, and standards. Coming from my DevOps background, it's kind of, that rubs you the wrong way, but like for finance stuff, it actually makes a lot of sense. And the goal is you want to have a cross-cutting team that understands what's going on with your cloud bill and how it relates to engineering and how we can save money as an organization. And so they've got a whole framework around best practices, and some of them actually are best practices, with principles, things that sound familiar for like us DevOps folks. Teams need to collaborate. People actually need to talk to each other. Everyone takes ownership of their slice of the bill, because you want to get these numbers in front of people. You might not be doing something as formal as chargeback, but you do want to have the idea of everyone understands what they're costing the organization, and maybe that's not a problem. Maybe your bank didn't go under yesterday, but different folks will have different takes on this, and so that O'Reilly book, Cloud Finops, it's written by a lot of the main Finops organization people. Second edition came out like a month ago, so go grab yourself that. Just read it. If you have to deal with the cloud bill, start reading this so you at least wrap your head around it. And then they're big on this whole crawl, walk, run. There's a lot of aspects to how you can optimize your financial positions with respect to cloud usage. You're not going to do everything all at once. It's an iterative process. That's my pitch for FinOps. I got myself certified just because it's fun, but it's a good idea. But let's talk about at the Kubernetes level. At the Kubernetes level, when we look at our stack of Kubernetes, at the top, we've got our workloads, our pods, our deployments, all the things that are running our applications. And then we've got the layer of our Kubernetes orchestration. It's Kubernetes putting things certain places, doing certain things. And then under that, we've got our operating systems, the OS, machines that are actually running it, our nodes. And then, our cloud infrastructure, it's our nodes, but our storage, our, whatever it might be that, we're paying, our cloud provider for. The cloud infrastructure is actually what shows up in your EC2 bill, right? All that other stuff is like, well, maybe you don't want Amazon to know that stuff, I don't know. But the point is, when you start thinking about optimization, you start at the top. You start at the top because everything you do compounds below it, right? If you save money in all your pods, well, then that means Kubernetes underneath it is doing less work. It's costing less. And then if Kubernetes costs less, maybe you need fewer operating systems. And if you need fewer operating systems, your cloud infrastructure bill gets smaller too. And coming back to the FinOps thing, you want to coordinate your savings across your entire organization because I might have my little engineering team and I can save us $40 a month or something, and that doesn't sound like it. But if that doesn't sound like much, but if there were 100 and 200 organizations like that in my thing, and we all just knocked off $100 off the bill, we just saved $40,000 a month for the company. So I mean, these things need to be coordinated because also well, we'll get to it, but this is an iterative process. You're not done. Sorry, there's no silver bullets. You just you kind of keep working at this and you revisit things and you're like, hey, what are we doing inefficiently today? How can we say what's the biggest chance to save money? So starting with our workloads, these are our applications running on Kubernetes. The simplest thing, of course, is to go and find those abandoned workloads. Find the things that you have pods that are receiving no network traffic and they're just sitting there. They're taking up valuable space. It might be an entire namespace, that is just running nothing but taking up space, and which means that Kubernetes might say, well, I'm not going to allocate that because it's you might need it later, and maybe it's abandoned. That workload's not coming back. Right-sizing containers. So once you've started looking at the numbers, and OpenCost is going to give you numbers, efficiency numbers, and say this pod, this this deployment, whatever, the stateful set is this efficient, this inefficient, has this much idle. You can say, well, hey, it's great that I gave Nginx 4 gigs of RAM, but I've been watching it for 2 months and it's never broken 256 megs. Maybe I could drop that down to a nice, 300 megabytes and save myself, 3.7 gigabytes of RAM. It's one less thing I have to pay for. You can do this programmatically. There are definitely tools that will go and allow you to, take the numbers out of OpenCost or KubeCost and right size your manifest. I'm not a big fan of automation, at least when it comes to the size of my pods. But this is the sort of thing that you can start to optimize. One of the things that a lot of shops don't do, surprisingly, is provide requests for their containers. When you deploy your container, you can actually say, I need a minimum of this much RAM, this much CPU, maybe a GPU. But kind of the general rules of thumb are you should always provide a request for your CPUs. You should always say, my CPU, I need this much, this half a core, two cores, whatever, I gotta have that. Limits are a little contentious. Some folks say never use limits. Some folks say, because what happens with the limit is when you provide a request. I'd like to have 2 cores at a maximum of 4 cores. Well, the next machine that comes in and says, I'd like to have 2 cores with a max of 4 cores. Well, the machine only had 4 cores on it, so they can't get scheduled to that box. So that second workload might get starved out. So maybe you just request what you're going to need, and everyone just makes requests, and you end up on a box that still has headroom. You're still able to burst into, take more CPU than you actually need because you're not limited. So that's kind of the happy path, hopefully. There are definitely places where you will want limits on your CPU usage. Because long-term cloud users know that you can be oversubscribed on a box for CPU. Because very rarely is your CPU running 100% max out. A lot of times it's kind of spiky, and you put 100 different VMs on the same machine, and they're all kind of spiky, and it looks like you can fit 10 pounds on a 3-pound sack. You can't do that with RAM. There's no such thing as oversubscribing for RAM. So you kind of want to just set your requests to limits. What's that? Okay, unless you want to page out to a hard drive or something, yes. Yeah. It's a bad idea for your containers to be page faulty. Yeah. Anyway, don't do that. Don't do that. Just keep it simple unless you know better. But at least put in some requests. That'll get your containers headed in the right sizing space. And managing unclaimed volumes. A lot of times when I start looking at people's deployments, they've got a bunch of just volumes that are not attached to containers anymore. They're still allocated by Kubernetes. You're paying for them eventually. So go find those, track them down. At the Kubernetes level, this is cluster configurations you can make for yourself. Right sizing cluster nodes. Maybe you deployed to a 5-node cluster and you're running 3 nodes worth of compute. Maybe you can go ahead and just reduce it down to 3 nodes. Or conversely, maybe you still need 5 nodes, but they don't have to be as big as what you deployed. So finding the right mix of the number and the size of nodes running your infrastructure, that's something that you're going to want to look into. Look at CPU, memory, storage, networking. Every one of those sliders is available, as a different compute type, from all your cloud providers. They're going to let you play with all those knobs. You don't want to waste any space on any of them, right? And if you are a fairly savvy Kubernetes user, you can start using nodes on demand. You can use spot instances for your nodes, and there's a lot of fun stuff you can do and getting your cluster nodes right. One of the really overlooked things is AMD nodes are like so cheap compared to Intel. There's no overhead of having to rewrite your stuff. It just works. But there's a lot more supply of AMD on AWS at least than Intel. So you can get AMD on the cheap. Pro tip. And then, of course, managing unclaimed volumes. Go clean that stuff up because you're paying for it. Operating system optimizations. So underneath your Kubernetes clusters, there's still more fun stuff you can do. Your machines may have additional drives or IP addresses assigned to them. If those aren't being used, get rid of them because you're paying for them. So you should get in the habit of going and kind of auditing your infrastructure just to see if there's stuff that's left over, because it's waste of money. Resizing local disk, again, once you have some sustained usage, you'll probably get a good idea what your capacity requirements are, so you can start reducing the size of storage that's needed. And of course, if your workloads are portable, move to ARM. It is, there are very few use cases where ARM is a bad solution. It's so much cheaper. It's like, Amazon will tell you for days and days and days. Azure and Google have Ampere boxes. There's a lot of money to be saved if you can move to ARM. And then cloud infrastructure optimizations. You've got a Finops team, right? And they're looking at all these different teams using all these different clouds, and they're looking at your bills. They can start coming in with these sorts of recommendations. Do you need reserved instances? Are your compute loads, are they running nonstop? Can we do something to, save on money, because we know we're going to be running them for months and months? Spot instances. We don't know that they're going to be running for months and months. Our workloads are bursty. Spot instances can get ridiculously cheap, especially the AMD ones. So I would say, look, if you can start using spot instances, you can save 70%, 80% sometimes on your machines. It has to mean that your workloads are capable of evacuating in a minute, but you're using Kubernetes, right? So, and then of course savings plans. Talk to your cloud provider. Once you start getting in on the Finops Foundation stuff, their Slack is full of people negotiation strategies, what you can do, what you can get out of Amazon, which reps are bad at their jobs. You see all sorts of fun dirt happening in their Slack. Essentially, and the weird thing I found out is you can have a savings plan every month. So rather than have one big, hey, we got a 3-year savings plan, you can be every month we're going to start another savings plan, and you just keep rolling them over. It's nuts. So then okay, well, apparently it's a business model. And then kind of this isn't a KubeCost pitch, but all the recommendations come out of the KubeCost UI. So it makes all those recommendations too. So again, start at the top, work your way through, iterate through the process, and the savings just keep going down, but start at the top. So that's all I got.